Sir, we'll wait for a few minutes, then we'll start.
Okay, fine.
Exactly at 6:30, we'll start, sir.
Fine. Last session, actually, I didn't get to this rapporteur report. I don't know, somebody has already taken some notes on the presentations.
Sir, we'll see that who is the reporter. I will contact with them.
Okay. I think as such that she was absent in that, so I don't know. Somebody
has taken the from our
yes.
side. I think
Yeah.
from our side somebody has taken that.
Okay.
Chairman, sir, can I start?
Yeah, I think we can start.
Okay, thank you. I welcome all of you in this very important plenum lecture. Today's speaker is Professor M. Manirul Kadir Mircha. He is the adjunct professor, Department of Physical and Environmental Science, University of Toronto. So today's session will be chaired by Dr. Balakrishnan Nair. He is a senior scientist and group director at the Indian National Center for Ocean Information Service, Hyderabad, India. He is one of the founder member of this organization, which is INCOIS, having over 25 years of experience as a researcher and leading the Ocean Information and Focus Service Group of INCOIS for the last 19 years. Dr. Nair was conferred with several national and international awards and fellowships, and he has vast experience on the different areas, particularly climate change, forest, and all forest related things. And he has published more than 75 papers in international and national peer-reviewed journal, in addition to many technical reports and popular articles. He is also the fellow of the Telangana Academy of Science. So I invite you, sir, to chair this session. In this session, Dr. T.D. Lama will act as a reporter. So now I request Chairman to start this session. Thank you very much.
Thank you very much. and it was really good for the chairing the last session. And I'm very happy to chair this session that is on Plenum Lecture 9. And it's also, I'm very privileged to introduce the speaker, Dr. M. Kotar Misra. He's actually from the Department of Physical and Environmental Science, University of Toronto, Scarborough, that is Canada. So Dr. M. Munirul Kotar Mirza has extensive research on hydrological and climate extremes, natural hazards and their management, climate change and water resources, and associated vulnerability, impact, and adaptation. He received his PhD from International Global Change Institute, that is IGCI, University of Waikato, New Zealand, on climate change and flood modeling in Bangladesh in 1998. He contributed as a coordinating lead author to the special regional report, the third assessment report, and the fourth assessment report of IPCC of UN, and the Millennium Ecosystem Assessment and the Global Agriculture Assessment. Actually, there is some problem in the light here. He's adjunct professor in Department of Environmental Science, the University of Toronto. He is a member of American Society of Civil Engineers and Professional Engineers, Ontario, Canada. And I'm very happy and enthusiastic to hear his lecture, because where my area is also the coastal vulnerability and the coastal services. So he will be giving a plenum lecture on coastal agriculture under future climate change. Can developing countries adapt? Over to Dr. M. Munirul Kotar Mirza.
Thank you very much. I'm just sharing my slide. Could you see the slides?
Yeah, we can see your slide. I think it is in presentation mode, no?
Yes, it is in the presentation mode, yeah.
Okay, thank you, thank you, thank you.
And good evening. And I thank the organizers to give me the opportunity to make this presentation. Climate change and coastal agriculture, can developing countries adapt? In the introduction, I would like to say that it is profoundly a challenging task to live in a low-lying coastal areas of developing countries. It is not a fun, actually.
I'll call you back at this number.
Hello? Presently, approximately 40% of the developing countries' population lives in the coastal areas. The coastal people and their economies are at constant threats of natural hazards. Life and livelihoods of the coastal population have been predominantly, by and large, dependent on agriculture. Heavy rainfall from cyclonic storms, high tidal flows destroy crops, salinity intrusion reduces agricultural productivity, waterlogging due to unplanned infrastructure development has proven to be destructive to coastal agriculture. In the last couple of days, you have actually heard about the coastal agriculture and present problems and future risk a lot. And I am not going to repeating those in my presentation. I am taking the science and policy routes, where our science stands now in terms of climate change, its risk and adaptation, and our need for better understanding of uncertainties of science and policy integration. So as I said, that coastal agriculture system is particularly vulnerable to climatic and non-climatic hazards. And they are more vulnerable than inland farming because along with rainfall and temperature changes, they have to also deal with frequent changes in ecosystem. And they experience increasing anthropogenic disturbances through land degradation and encroachment of agricultural lands. In this slide, what you see is the effect of threshold level of global temperature anomaly above pre-industrial levels that leads to significant local changes in terrestrial ecosystems. The regions colored in dark red are projected to undergo severe transformation under a global warming of 1.5 degrees Celsius, while those colored in light red do so at 2 degrees Celsius. And you also see a significant areas of global coastal regions. The ecosystems are threatened by 1.5 degrees Celsius global warming. The next slide, it shows extreme sea level rise. This is taken from a recently published article in Springer science report. And the total sea level is function of time, and it is comprised of tide, storm surge, and wave setup. And this figure demonstrates 100-year return period of extreme sea level. And the models are extensively validated against the tide gauge data. Global hotspots show significant change in episodic flooding. Without any adaptation or protection, the authors project an increase in 48% of world land area will get flooded, 52% of global population, and 46% of global assets. And these are the people and the assets live in the coastal areas, and assets are also located in the coastal areas. A total of 68% of global coastal area flooded will be caused by tide and storm events, and 32% will be contributed due to projected sea level rise. And this figure shows the regional 100-year extreme sea level rise, and Indian subcontinent and the adjoining areas are here, and China is shown in this figure. Climate change alone cannot create significant disaster risk. And this figure we have developed in the IPCC's special report on extremes, published in 2011. And what you see here actually, that is like a nutcracker. On the left-hand side, you see climate, includes natural variability and anthropogenic climate change. And on the right-hand side is development. That is also a function of disaster risk management and climate change adaptation. And these two, together with weather and climate events, vulnerability, and exposure of the system, will create much higher disaster risk. In this slide, we see the threshold temperature for some crops. And this is the optimum temperature. And the last column is temperature for factor productivity. And what is important here is whether we are addressing the future risk in terms of extreme temperature. And that will be very important, because the crop varieties we are trying to develop now to withstand future climate change. And in the coastal areas, scientists are developing crop varieties to withstand higher salinity exposure. And also, scientists are developing varieties that can withstand longer flooding period. And all these have to be prioritized in scientific development programs if you would like to adapt to future climate change, especially in the coastal region. So where do we stand actually in terms of global temperature change? And this figure shows global temperature anomaly from 1951, correspond to 1951 and 1980 average. And 2019 global temperature was 14.9 degrees Celsius. Under the Paris Agreement, we are targeting global mean temperature is 15 degrees Celsius from the pre-industrial. How close are we to 1.5 degrees Celsius? We are actually, last year, the National Oceanographic Administration of United States of America released one piece of information that 1/3 of the global population last year actually they experienced on average your 15 degrees Celsius temperature. However, the IPCC 1.5 degrees Celsius special report mentions that at the current rate of increase in global mean temperature, and we will be by 2040, actually, like 2 decades from now, we will be reaching there. And the urgency is to devise action plans as quickly as possible to contain the temperature at this level. How could we do it? This figure shows the conceptual pathways that limit global mean temperature to 1.5 degrees Celsius. On the left-hand side, we need a drastic reduction. And then we stabilize after some time. And on the right-hand side, it shows that we allow to pick it up at certain point, and then gradually we reduce it before returning later in the century. The COVID-19 has created an impact on the efforts of greenhouse gas emissions because our economic activities in the last 1 year is more or less stalled. But what would happen actually, the scientists are projecting that to maintain economic growth, we need to actually expedite our process of productivity, and that means we will actually shoot up more emissions in the near future, and that might affect our effort to contain 1.5 degrees Celsius temperature later in the century. Our ability to understanding extremes, where it lies. We are very good at understanding extreme heat and extreme cold. But if you look at here, our understanding of these type of extreme events is actually, our confidence is less. For example, one is drought, and then extreme rainfall, and tropical cyclones are further down, and extratropical cyclones, our understanding of wildfires, and severe convective storms. So these are the extreme rainfall, tropical cyclones, and droughts, and severe convective storms and extratropical cyclones. All these will affect or are affecting the coastal regions. And so what we need actually, we need to increase our ability to understand all these events, and that will help us developing policies and programs for coastal agriculture. This figure shows the increase in global mean temperature by the end of 21st century relative to 1986 to 2005. And this box is the historical part, and these are the future projected temperature. And what we are doing actually, right at this moment, we are designing all coastal infrastructure based on our historical precipitation, historical tide gauge data, historical your storm precipitation, and historical storm surge data. But a group of scientists of our IVCC colleagues in 2008 published a paper in Science, and they argued that actually the stationarity is dead. We can no longer design our infrastructure, especially in the coastal regions, based on historical data. We have to consider the future projected climate. So how did stationarity die? Stationarity is dead because substantial anthropogenic interventions, because we are altering Earth's climate. Warming augments atmospheric humidity and water transport. Per degree global warming actually will increase 7% increase in vapor pressure. And the increased precipitation would likely to cause increased flooding, and rising sea level will inundate coastal infrastructure. Glacial meltwater temporarily enhance water availability. It could be a big problem actually for the Ganges-Brahmaputra delta, because in the short run, we will see an increase in water availability in the dry season, but in the long run, we will see water scarcity in the dry season. And then, what is the relationship between mean and extremes? If there is a shift in the mean, and that means we are expecting your more extreme hot weather as probability will change. Next figure, I will give an example from Bangladesh. This is from Warwick et al. And when we first worked on a Ford Foundation project on climate change and sea level rise impact on Bangladesh. And what we took the historical rainfall data. And in 1974 was a flood year. And also that flood caused significant damage to crop. And that led to a famine. And in the 1974, over here, the probability of occurrence of 1974 extreme rainfall is 0.0017. And that is the return period is 588 years. But with a 12% increase in monsoon rainfall by 2030, that probability reduces to 0.0207. And the return period becomes 48 years. And that means the probability of occurrence of that threshold of rainfall, it is 12 times more likely. The number of people, how many millions of people with increase in water stress by 2080? These figures determined by our colleagues in IPCC 2000 fourth assessment report. And there are two key messages from this figure. One is that most of the water stressed people will live in Asia and Africa. And the other key message is that no continent is actually will be immune from your water stress by the end of this century. and food security. Coastal areas are more vulnerable to food security issues because, as I said, that in addition to regular temperature and precipitation variability, and coastal agriculture is also vulnerable to sea level rise and storm surge, tidal inundation, and especially salinity. We have made significant progress in food security since 1990, but still about 1 billion people go to bed without any food every night. And recently, we have also noticed that number of undernourished people are on the rise. So how the global agriculture would look like under future climate change? Based on many studies covering a wide range of regions and crops, negative impacts of climate change have been more and common than positive impacts, and it is high confidence iterated by Intergovernmental Panel on Climate Change. And you can see that the yield impact and could be significant, and more for, in terms of percentage, more are expecting for wheat and then rice and followed by maize. There is a high confidence that cereal productivity decrease above 3.5 degrees Celsius, global temperature increase. This is the conceptual framework on climate change and the food security. And the climate change variables, CO2 fertilization effect, increase in global temperature, changes in precipitation, all these. And together with changes in food system assets, changes in food system activities, and changes in components of food security. And all these are interrelated. And after every cyclone in the coastal areas, whether it is in the eastern part of India or it is in the Bangladesh coast, what we have seen, a problem of food security, and addressing those food security problem is a challenge. It remains as a challenge. And in future, this challenge will be larger. What is the investment scenario of in global agriculture? By 2050, world population would be 9.1 billion. And that is 34% higher than today. And urban population will be 70% of the world population, and food production must increase by 70%. And annual cereal production would be 3 billion tons, and meat production to increase 470 million tons from 200 million tons. Developing countries are invested 142 billion annually in agriculture, but 83 billion additional investment would be required. The hunger situation is not going away anytime soon. Amartya Sen said the existence of massive hunger is even more of a tragedy because it has been largely accepted as being essentially unpreventable. So why adaptation is important? Adaptation is important because if we look at the historical chronology, and we see that we have been trying to adapt to extreme weather events. And with all the resources and technology and the knowledge we have, but problem is that we are unable to adapt to catastrophic events. Always there is a limit. That limit is caused by many factors. Let's look at what are the factors. Impacts are expected to increase with increases in temperature. Then early impacts can be effectively tackled with adaptation. In the IPCC's fourth assessment report, a conclusion we have drawn that until 2030, we would require extensive adaptation measures, planning and their implementation at the field level. But then because adaptation has limits, so we need to focus on mitigation. And if we start efforts to mitigate the greenhouse gas emissions, and there is a time lag, and then that will take effect after 2030. And then we have not enough knowledge on the barriers, limits, and cost of adaptation. Adaptation alone is not expected to cope with all the projected effects of climate change. The limits and barriers to adaptation, physical and ecological limit. We have physical limits and we have also ecological limit. We cannot address all the physical limits. For example, in the next slide, this is what it would look like with 1 meter sea level rise and 1.5 meter sea level rise on the Bangladesh coast. We cannot, it is not physically possible actually to close this estuary. It is not physically possible. Also, it is not physically possible to put coastal embankments everywhere. Then we have technological limits. We don't have all the technology and to adapt to future climate change, and financial barrier would remain very significant. Globally, it is said that 175 to $200 billion per year is required for the developing countries. That much investment is required for adaptation activities. And then we have informational and cognitive barriers, and we have social and cultural barriers. When scientists develop a new variety of crop, and then it remains a big challenge to get it accepted by the farmers, because farmers considers many factors. For example, when they are adapted to a particular variety of crop, they do not like to actually switch to a new variety. And the knowledge they gathered from generation to generation, and then educating them in new knowledge for the new variety of crop would remain a challenge. So coastal agriculture, our science and policy challenges, what are these? We need good science for good policies. And then we need to have better understanding of extremes and uncertainties. Because in future, probably in many places, extremes will be the new normal. And we need to understand how the future extremes will unfold, where it would unfold, and how frequent it would be, and what would be the magnitude of uncertainty associated with extremes. Then we must consider non-stationarity in the codes and standards for coastal infrastructure design. For example, if you would like to design a coastal embankment, we must consider future sea level rise, future storm height, etc. for the coastal infrastructure design. And then bottom-up science research agenda we must pursue. We need to go to the grassroots level people, go to the stakeholders to understand their requirement. And then mainstreaming of science and blending with that with policies will remain a challenge. And what we have seen, we implemented a project in Bangladesh funded by the Asian Development Bank in 2011 to 2013. What we noticed that there are significant gaps in interdepartmental cooperation. And also there are gaps in integration for research and application for both adaptation and mitigation. And we must address this. Then how we could address the problems of the marginal and the most vulnerable farming communities. Lands are becoming fragmented, families are getting larger, and the economic capability of marginal farmers are small. And with every extreme weather events, actually their capacity goes down. And in future, with frequent extreme weather events, the likelihood is high that their capacity would further go down. But how we would address that? And coastal agriculture needs additional attention as the problems are different than the inland. And we must address the security of health, especially the women and children, and livelihoods need to be addressed. Innovations are good. I have heard many presentations that our scientists are doing excellent work to adapt to future climate change. But how to outreach those to the farmers and to the policymakers? And finally, the financing of adaptation and mitigation programs will remain a challenge, especially for the coastal regions of developing countries. Thank you.
Thank you, Dr. Mirza. It was an excellent talk. I really enjoyed it. So I have a couple of questions, but I will request the other audience if you have got some questions. Yeah, I think, yeah, Dr. Sen has a question, or Dr. Sen, please.
I enjoyed your talk, and I have this kind of question in a different mode.
Yes.
Number one, the climate change and sea level rise as a consequence of climate change because of El Nino and other factors, they are going unabated. You can't stop it so easily. It will go. But there are predictions how long it can go. The kind of intervention that worldwide, as for Paris Agreement and otherwise, we are taking care. But these are superimposing factors. Coming to coastal agriculture in general, coastal agriculture, unlike inland agriculture, be it salinity, be it something else, is a different nature completely. And you have rightly put the word stationarity will die. It has died already. I would put it in another mode. Can you have a kind of generic study? Can you plan as scientists to take care of the factors that eliminate some of the factors that influence the coastal agriculture problems, deteriorating the hydrologic behavior of the river waters, underground water, and so on and so forth. Because today a variety is developed, I say this variety is good for Morishal area. Okay? And we also go to the extent that it is good for that particular area in Borishal. What is true today will not be true for tomorrow. So we have to look in for some kind of generic development in our strategies to possibly develop a kind of models. I don't know whether it's possible or not. Climate change is a superimposing factor to this. But unlike inland areas, I don't know whether I'm clear or not. I'm trying to impress upon all the people here, including you, that coastal agriculture has to be taken. It's so heterogeneous in character. Spatial and temporal variability is so much. We know the factors, but we hardly try to understand the complexity of it, the factors influencing them. Say, for example, I have seen the literatures in Bangladesh, there the salinity is increasing in majority of the areas over time. So also, I guess there are no systematic studies in Indian part of Sundaban so far over a long period of time, but given a chance to study over a period of 30 or 40 years or 50 years, definitely it will end up with a rise of soil salinity and poorer quality water in course of time. We have to understand the factors. This is what I mean to say, a kind of genetic study, which will eliminate which will take care of all the factors and possibly arrive at some kind of prediction value. And of course, climate change and sea level rise also will be superimposing factors to this. This is what I suggest, and possibly, I don't know whether I could convince you, but this is what you mean to say. You meant to say the stationary code have died, and that has to non-stationary code have to be taken into consideration. I tried to elaborate the facts by saying non-stationary code have to be included in that. I have not seen the paper you cited, but if the paper I would have gone through, then possibly this kind of indications must have been there. This is what I submit to you. And to me, it appears to be very, very important. Unlike inland salinity, once it is reclaimed possibly forever. It is possible to reclaim forever, not in coastal areas. Today you reclaim, tomorrow it will come up with a little bit higher salinity. Day after tomorrow, a little bit more salinity and all that. So do you think you go on finding out varieties and management practice for each and every situation for every 2 or 3 years or 5 years interval? It's not possible. Humanly not possible. You can make papers, you can make publications, you can make presentations in seminars, but that's not all. Thank you very much.
Yeah, thank you very much. I will think about it and I will email you the paper, the science paper.
Yeah.
Okay. Yeah. Thank you very much for your very constructive comments.
Thank you, son. And any more questions to Dr. Mirza?
Dr. Manoranjan Mandal has raised his hand.
Hello.
Yeah. I think you can proceed.
Can you listen me?
Yeah.
Yes,
Okay.
you can.
Thank you very much. I was listening the whole afternoon. Unfortunately, I could not see my observations and then other things to ask. But at the last, I saw the presentations of Monjul Mirza and then others. So there are so many frustrations, challenges, problems, but there are opportunities also. I will see that like salinity. So if we can, if salinities increase, then there are opportunities. Yes, it will not change overnight. But Dr. Shane mentioned that 5 years, the scientists are not keeping idle. There is a momentum of developing salt-tolerant varieties, but there is a limit. But if crop agriculture will not fit, aquaculture will fit. So I am hopeful. I'm not really that much disappointed with the sea level rise or salinity increase. So at present, the model predicted that rice, wheat, and crop yield will decrease. But who knows? Due to temperature increase, there will be some varieties from C3 to C4 crop that will boost up productivity. That increase in temperature or solar radiation will be a blessing. Thank you.
Thank you very much, Dr. Mandal. And I appreciate your comments. But I have one observation, I tell you, from the coastal region of Bangladesh. And you see, the farmer who is adapted to grow rice, if you ask that person that next year you will start growing wheat, it is difficult for him. As because we always try to do what we know of and we are sure of. And these marginal farmers, most of them are marginal farmers, they actually do not like to take the risk. And aquaculture needs actually large scale investment. And these marginal farmers, they don't have that much of resources to invest in aquaculture. Only the commercial farmers, those who do the commercial farming, only they are able to do it. If you go to Satkhira region of Bangladesh, what you would see that the shrimp culture that started in the 80s and 90s and then expanded in the 90s, actually now shrinking, but it actually leaving behind a highly saline land that is actually not suitable for any kind of crop. And there are also discourse about migration of coastal population to somewhere else. But this is also another problem, what they're going to do in the urban areas. Because trained on something, and then they have to actually accept something new. This will remain challenge, but our scientists are doing excellent work. And they are developing crop varieties. And I am not pessimistic, because you see, when in the 1960s we had tremendous food shortage, especially in the Indian subcontinent, and we conquered that. And with the introduction of high yielding varieties. And probably we will also be able to conquer the challenge of climate change, but it will take time, and also it will take a lot of investment of a lot of knowledge and resources.
Very quick update of the coastal zone of Bangladesh. I am from Bangladesh, and I am working, I was born and brought up in the coastal zone. And I am working there for more than 30 years. So what the present agriculture, we have seen the farmers in the high saline zone, they have converted their shrimp farm into a small fish, rice fish system. In the wet season, they grow white fish, they call white fish, this not the shrimp, not the saline water. And then they conserve the rainwater and then go for boro rice inside the pond. And then on the dike, they go for year-round vegetable cultivation. So this agriculture is expanding rapidly in the Satkira, Khulna, Koira, Paigasa, Dumuria in this belt. So that is one thing. And since you are familiar with the coastal zone, in the south central coastal zone is really a very good opportunity for Bangladesh to boost up agricultural productivity. This is the whole year, the river, especially the Paira, biggest river, are flowing are carrying non-saline water. So this challenge, I think Monirul Islam, Tariqul Islam has presented that the IWM predicted that until 2050, the salinity will not, that in the south central Borishal region will not change that much, but it will drastically change in the southwest, especially Satkira region. So, but in the Satkira region, the farmers are converting this from shrimp, bigger shrimp farming to a smallholder fish, rice fish system, rice fish vegetable.
Okay, thank you.
Yeah. Is there any more questions? Otherwise, I want to ask one or two questions, that's layman questions. Sir, it was an excellent presentation. I enjoyed it. I am a marine scientist. I am not an agriculture scientist. But I feel that the work actually have a lot of implications. One thing I want to ask you is that when we are talking about adaptability, due to this sea level rise, storm surges and other things in the coastal area, what I feel is that in many of the coastal areas, we have already a traditional wisdoms or traditional kind of a agriculture methods. Like for example, in Kerala, what I feel is that actually there is a kind of a agriculture methods which they adopt below the mean sea level, like the Kuttanad in Kerala. So whether you feel that that kind of a agriculture methods should be encouraged and more research has to be research and technology has to be invested in that for actually adapting this climate change for the coastal agriculture. That is one my first question. Second question, most of our coastal agriculture or kind of a coastal zone management, they still actually adapt stationary. So you are already telling that stationary already dead. So whether you feel that we should have more kind of a dependability on numerical modeling techniques, which can predict the changes in the environment, and also with that we can make a using this information we can make better policies than depending upon the stationary data what we are already depending. So these are my two questions to you.
Thank you very much. In my presentation, I mentioned one point, that is that bottom-up science research agenda. We need to go to these people actually. It is a requirement for our scientists as well and the policymakers, and to ask them actually what do they want. And these people, they have been living there thousands of years and they have enormous amount of knowledge. to adapt, as they have been adapting, or they have been actually facing this kind of onslaught of natural hazards for, for thousands of years. And generation after generation, the knowledge base transferred to next generation and then next generation. And integrating their knowledge with our advanced science knowledge, we will actually create better outputs, and also its acceptability will increase to the people that are living in the grassroots level. And yes, we have advanced a lot in terms of modeling. And for the coastal region, the imperative is that we need to develop complex ecosystem model, because it is changing all the time. And coastal regions are very, very special area where ecosystems are changing. Ecosystem is continuously, it is a challenge, and it will remain a challenge. And better understanding of coastal ecosystems through modeling and the interactions of all the parameters, the salinity, freshwater supplies, and tidal surge and the storm surge, yeah. And all these should be incorporated in a model that will interactively model the outputs. And also, as you said, that the traditional knowledge of the coastal people, and those will actually help us developing this kind of model more effectively.
Thank you very much. So I'm really enlightened, and we got a very good speaker for this plenum's talk. And I thank on behalf of organizers, I thank Dr. Mirza for a very enlightening talk. And even as a layman, as another scientist from other area also, I enjoyed your talk. So thank you very much. And also I thank the organizers for giving me a chance to chair this session. Thank you very much.
And thank you very much, Professor Sen and the organizers, to kindly give me the opportunity to address this August gathering.
Now it is my responsibility or task to spend a minute on behalf of the organizers to thank Dr. Nair and Professor Manirul Mirza for the excellent talk that he has presented. It gives a lot of food for thought for the future, in fact. But I pose certain questions myself, but then I have tried to pose it to the right person. Possibly it will make him think and suggest in future through personal contact or otherwise. So thank you very much. I think everybody is enlightened by your talk and can develop in countries, because in US or Canada, where we are living, it is more of a recreational mode. People try to live in the coastal areas. It has got high aesthetic value, and they don't bother for agriculture in the coastal area that much as we do. India, Bangladesh, Sri Lanka, Vietnam, and all that. So we have to be, because it is our bread and butter, we have to be very thorough about it, think it for ourselves, what to do and what not to do, and develop the program for ourselves for the future prediction and developing future strategies to combat the adversities. Thank you very much on behalf of the organizers. Thank you, Professor Mirza. And I know you are so busy. And so thank you so much. Dr. Nair, thank you very much.
Thank you. Stay safe and
you.
healthy.
Thank you.
Thank you, all of you.
Thank you.
Now, before closing the session, I want to just make a few short announcement. Tomorrow, we'll start our program with the plenum lecture at 9:30 IST. There is two plenum lecture. One is by Dr. Sanjay Kumar Srivastava on the topic building the coastal resilience in Asia and the specific opportunities and challenges. Another one by Dr. P.K. Joshi. His talk will be on coastal ecosystem, explore value chain, processing and exports for the poverty alleviation. After that, we have very panel discussion where there will be a lot of experts will be there from the different sectors. They will be discuss on the topic addressing the coastal problems or improving the economic and livelihood security. And after that, we have the very important session in the afternoon that is from 2:30 in IST time. That is plenum session. We are all requested to join the tomorrow's program. Thank you.
Thank you.
Thank you very much.
Thank you.
Thank you. Thank you.